From today onward, I will spend a lifetime telling the internet about the cosmos. Even if for now, only a few signals are listening, and if one day this channel gathers millions of people who still look up at the stars with wonder, then that will become a cosmic romance created by both you and me. When I was a kid, Mars felt different from every other world in the sky. Jupiter was bright, Saturn was beautiful, the moon was familiar, but Mars felt personal. A red point of light that seemed close enough to imagine, but far enough to remain mysterious. I remember staring at it through a small telescope and thinking the same thing millions of people have probably thought before me. What if something once lived there? Not cities, not little green people, just something small, something microbial, something that once moved through ancient Martian water before the planet became cold and dry. For a long time, that idea sounded like science fiction, but now, NASA keeps finding pieces of a much stranger story. Organic molecules, ancient lake beds, clay-rich rocks, possible biosignatures, and the more we learn, the harder Mars becomes to ignore. Tonight, we explore why Mars may be giving us the strongest hints of ancient life yet, and why those hints still may not be life at all. In April 2026, NASA reported that Curiosity found organic molecules never seen before on Mars. The sample came from a rock nicknamed Mary Anning 3. Curiosity drilled it back in 2020 in a region of Mount Sharp where lakes and streams existed billions of years ago. After years of laboratory work inside the rover, scientists identified 21 carbon-containing molecules. 7 of them had never been confirmed on the Martian surface before. That sounds huge. And it is, because organic molecules are the chemical building blocks of life as we know it. Carbon is the backbone of biology on Earth. It appears in proteins, sugars, fats, DNA, RNA, and the chemistry of living cells. So when we find complex carbon chemistry on Mars, the obvious question appears immediately. Is this evidence of life? But this is where science becomes careful. Organic does not mean biological. That sentence is extremely important. An organic molecule is simply a molecule that contains carbon. Some organic molecules are made by life. Some are made by geology. Some can arrive from meteorites. Some can form through chemistry that has nothing to do with biology at all. The universe is very good at making carbon chemistry. Life uses organic molecules, but life does not own them. That is the first trap. The second trap is that Mars is old, very old. The rock's Curiosity studies can be billions of years old, and Mars today is not gentle. Its surface is cold, dry, bombarded by radiation, exposed to thin air and harsh chemistry. Organic molecules should be difficult to preserve there. So when NASA finds them still trapped inside ancient Martian rocks, that matters. It means Mars did not just have water, it had chemistry capable of preserving some of the ingredients associated with life. That does not prove life existed, but it keeps the question alive. And Curiosity is not the only rover making Mars harder to dismiss. In 2025, NASA reported that Perseverance had studied a rock called Cheyava Falls in Jezero crater. That rock came from an ancient river valley, a place where water once flowed. The rover collected a sample from it, named Sapphire Canyon, and what made the rock famous were strange patterns on its surface. Scientists called them leopard spots, tiny dark-rimmed features surrounded by lighter material. On Earth, patterns and minerals like these can sometimes be associated with microbial activity. The rock also contained organic carbon, sulfur, oxidized iron, and phosphorus. These are not proof of life, but they are the kind of ingredients that make scientists lean forward. Perseverance also detected minerals such as vivianite and greigite. On Earth, vivianite is often found around decaying organic matter, and certain forms of microbial life can produce greigite. That is why the sample became so interesting. It did not just contain one strange clue, it contained a combination of clues. Water history, organic carbon, energy-related chemistry, mineral patterns, possible reaction fronts, a setting that once may have been habitable. But again, the word possible matters. NASA did not say it found life on Mars. NASA said it found a potential biosignature. A potential biosignature is something that might have a biological origin, but requires more data before scientists can say whether life was actually involved. That is a very careful phrase. And it should be, because Mars is dangerous for hope. It gives us just enough to imagine life, but not enough to prove it. The same mineral patterns that could be linked to biology might also be produced without life. Heat, acidic conditions, reactions between minerals and organic compounds, non-biological chemistry can imitate biology. And this is one of the hardest problems in astrobiology. The universe does not label its evidence. It does not say this molecule came from a microbe. It gives us rocks, minerals, isotopes, chemical patterns, textures, and then we have to reconstruct a world that disappeared billions of years ago. Imagine trying to solve a crime scene after the room has been frozen, irradiated, buried, dried out, and left untouched for 3 billion years. That is Mars, a planet-sized cold case. And the suspects are life and chemistry. Personally, I find that more fascinating than a simple answer. Because if Mars once had life, even microbial life, then biology may not be unique to Earth. It would mean life began twice in one solar system, once on Earth, maybe once on Mars. And if life can begin twice around one ordinary star, then the universe may be far more alive than we imagined. But if Mars had water, organic molecules, habitable environments, and still never produced life, that may be even more disturbing, because it would mean the ingredients are not enough. You can have lakes, you can have rivers, you can have carbon chemistry, you can have minerals and energy, and still nothing. No cells, no evolution, no living world. Just chemistry that almost became biology, but never crossed the line. That line is the real mystery. Where does chemistry end and life begin? We often talk about life as if it is obvious. Something either lives or it does not. But at the beginning, the boundary may have been blurry. Molecules copying themselves, energy moving through systems, chemistry becoming more organized, patterns becoming stable. At some point, something stopped being just chemistry and became biology. We know it happened on Earth. We do not know how often it happens elsewhere. Mars may be the closest place where we can test that question. Not because it is alive today. It probably is not, at least not on the surface. But because it may have preserved ancient clues. Curiosity's organic molecules tell us that complex carbon chemistry can survive on Mars. Perseverance's Cheyava Falls sample tells us that some Martian rocks contain textures and minerals that are suspicious enough to demand serious study. Together, they do not prove life. But they make Mars feel less dead, not alive, but suspicious. And maybe that is the most honest word. Suspicious. Mars is suspicious. It has too much history to ignore. It had rivers, it had lakes, it had clay minerals, it had organic molecules. It had environments that may have supported microbial life, and now it has samples waiting for answers. But the best instruments may not be on Mars. They may be here on Earth. That is why sample return matters so much. Rovers are incredible, but they are limited. They are laboratories on wheels, built to survive another planet. Earth laboratories are different. They can use larger instruments, more precise measurements, more destructive tests, more scientists asking new questions years after the sample arrives. A rock on Mars can whisper. A rock in an Earth lab can be interrogated. And that may be what Mars needs. Not more excitement, not more headlines, but patience. Because the answer is too important to rush. If we say life too early, we risk turning science into entertainment. But if we dismiss every clue too quickly, we may miss the first real evidence that Earth was never alone. That is the uncomfortable place we are in now. Mars has not answered us, but it has stopped being silent. It is giving us chemistry. It is giving us patterns. It is giving us ancient environments that look more and more like places where life could have tried. and maybe failed, or maybe succeeded. So here is the question I want to leave with you. How much evidence would be enough for you? If NASA finds organic molecules, ancient water, strange mineral patterns, and possible biosignatures, but no fossil cell, would you believe Mars once had life? Or would you wait until the evidence becomes impossible to explain any other way? Some people think we are getting closer than ever to proving ancient life on Mars. Others think we are only seeing chemistry and projecting our hopes onto a dead planet. I want to know which side you are on, because maybe the most haunting possibility is not that Mars once had life, and it is not that Mars was always dead. The most haunting possibility is that Mars came close, that it had the water, the chemistry, the time, the chance, and then, somehow, life never began.